Okay, for the sake of the video, there was a question pop up over the break that it's about staying after class, and there will be time for that. Our course is scheduled 1 to 3:50, and the general plan is we'll go for about an hour, take a quick break, go for about another hour, and then we have some time to work on stuff. We can call it lab time, but especially when we start actually looking at databases and working through small examples, even though our um, uh, even though our actively doing things in the database homework's not due until later in the semester, we'll still see examples and stuff along the way. So I want to make sure there's plenty of time to do that stuff or work on the homework in general while I'm sitting here ready to answer questions. So we'll go for about an hour, take a break, go for about another hour, and then the rest of our scheduled time, I will just be sitting in my office, which is directly across the hall from the classroom we're in here, and waiting for questions to come my way. So it's a great time to work on stuff and do things. So there'll be time to address questions afterward. Got some notes about getting started, but first off, there was one thing I forgot in the introduction. I was asked to do this last week. Let me share the screen, which seemed very, very short notice. Is anybody planning on going to another school after this? Like to a four-year school? I see there's one big head nod in the room, and I know at least one of the people on the Zoom call indicated that before. Well, the advisors put together a transfer fair tomorrow. They told me about it last Tuesday. So during spring break is when it seems, as far as I can tell, it was scheduled during spring break. And I was like, well, it's on the 22nd. I will tell students about it on the 21st. More notice would be good, but there is still some notice. So tomorrow, all these other representatives from all these other schools and more, because obviously after they made the flyer, they kept making phone calls looking for more people, are going to be here on campus, right? Yeah, at Fowl Hall. So that's the building up front. It's a German name. People who have never spoken any German, PF always looks strange. It's pronounced the same way as we would say the word helpful. So we pronounce both letters, but it throws off Americans to see it as the beginning of a word. So it's Fowl Hall is the building up front. When you walk in the big glass doors, the big lobby area there. So there's going to be representatives from all these different schools. So if you're interested in transferring, they will be there to answer questions or promote their school in general between 11:30 and 1:30 tomorrow. A lot of people started at Ivy Tech because community college is a little cheaper than some other schools and a lot cheaper than some schools. Way cheaper than some schools. Their schools, well, I had a whole bunch of cousins who went to Olivet over in Illinois. A whole bunch of people in my family wanted to go there. And I think one class there is about the same as an entire 2-year degree at Ivy. So there are some very, very expensive schools out there. So, but they teach the same English and college algebra that we teach here. So save a few bucks. A lot of people like to do that. And if you're one of those people, that transfer fair might be a good thing to look into tomorrow. I know it's not much notice, but I just heard about it last week. So I want to make sure y'all know about that. I mentioned the new technology report, and right this minute, there is a bunch of new technology being released. NVIDIA GTC. So NVIDIA, y'all probably know their names from the graphics cards, GPUs. They make other hardware as well, and a lot of other stuff, but they make the hardware. So twice a year, they have this conference called GTC, which is a developer conference where they make, it's a big worldwide event, and they train developers, programmers, how to do stuff on their hardware, on their latest newest hardware, talk about the latest hardware, so that other people can start releasing ideas to do with it and stuff. But a whole bunch of new technology just came out recently, or a whole bunch of interesting things. It's all about AI this time. In the fall, they have it twice a year, so the one in September, you can see the keynote was 3 hours ago. It was at 11 o'clock today. I watched some really interesting things. I jotted down a couple notes because I knew I was going to tell you all about some stuff here. If you want to watch that keynote, it'll be on YouTube before long. It might already be on YouTube. But the live session was just a couple hours ago. We had some really neat technology to talk about. As far as relating to this class, at their conference in the fall, as they were announcing all their 5-year plans, every single 5-year plan NVIDIA has involves CPUs, GPUs, and DPUs. You may not have heard of that as much, but that's data processing unit. Just like CPUs are optimized for that complicated calculations. Sometimes we don't need that. Sometimes there's just a lot of stuff to do, but it's not complicated stuff to do. It's not complex stuff to do. It's just a lot of it. The best analogy I've ever heard from it for comparing the GPU to a CPU goes with the cars. A Ferrari is almost always better than a van, except on moving day. A Ferrari is going to be kind of useless on moving day if you just have a whole bunch of stuff to move. So that's the comparison there. And then there's another special piece that doesn't, in the past, hasn't showed up as much, but NVIDIA is working it into every single one of their 5-year plans. So it's going to be around a lot. And that's a data processing unit where it's optimized for moving large quantities of data, which relates directly to our class, right? So there's a lot of those. And then this one was all about AI. Start scrolling through here to talk about AI, AI to accelerate scientific discovery, generative AIs for nerfs and virtual worlds. Yeah, you talked about that in the keynote. So anybody that's like in game development or something, generative, basically this week they're releasing the generative AI to make you 3D models and all the stuff you'd use building a video game to save some kind of some of the work there, which is the most time-consuming part of game development. It's all about AI. So they had a bunch of that stuff. If you want to look for new technology, just look for Google NVIDIA GTC or whatever search engine you use. And or the keynote from NVIDIA GTC conference is probably already on YouTube or will be soon. They have some really interesting things to talk about there. One of the first things I put on my note was that they've successfully connected GPUs to quantum computers. And that kind of made me laugh because they've worried about connecting GPUs to them before they got them fully working. Like, I would have focused on getting them working first and then added the nice graphics. But a big one is there were some major advancements in vector databases, or at least they announced that, which wasn't on the list of types of databases we're going to talk about in this class, but I will probably include that because that's something that can, if NVIDIA announced it, I can pretty much guarantee you that it's going to be in your future related databases. So I'll work on some stuff with that. Another way to handle that. Some other advancements and stuff. They got this really nice new CPU. It has 72 cores each, and they put 2 of them together. So really, it's 144 core CPU that will be running at 1 terahertz speed. Really, really impressive chip. But some other stuff that, yeah, and some other stuff that's interesting. But that would be a good place to look for new technology. And that one especially is that conference is happening this week. So every day this week you can go see different sessions, hear different updates and stuff. They have workshops where they actually do training. Those aren't free. Those cost money. But a lot of the sessions, as long as if you go Google NVIDIA GTC and you'll see a link for session catalog, start scrolling through those. The ones called workshops cost money. Those are $150 a piece and they're probably all sold out already anyway. I think the closest they would, any of those would be to here is Santa Barbara. But on the session catalog, if you scroll through there, a lot of those are free things you can watch. And as long as they wrote the label is written in English, you'll be able to understand the person talking. So just make sure that you only click on the labels written in English, which probably would have made sense anyway. With something like that, you can see how those conferences go together. Because for some of the other big ones, they've drifted into where their annual conference has just become purely a commercial. Apple's the big one on that. Used to be the annual conference where they announced the latest newest stuff, but anymore, Apple lets the developers and retailers and everybody know about the latest newest stuff a month before the conference, and then the conference is like a 3-day commercial. Makes sense. It's business. Got to run the business. Got to do the marketing, and gathering everybody for a conference is way better marketing than showing them an ad on YouTube. But other companies have done the same thing. So that NVIDIA one will be have a lot of up-to-date information. And a few things that relate to databases, but they were mostly talking about AI this time around. And okay, so that was everything on my preview list. That transfer fair, probably some interesting information if anybody's thinking about transferring. So now, I guess we can start into some of our material. I'm going to start with 2 words. I'm going to give a loose definition right now, but because of what I wrote on the first page of notes to talk about, the introduction of how we're going to approach databases in this class, I want to make sure, I wanted to give the loose definition of this word first. We'll see the formal definition probably next week. The 2 words we're going to see a lot, join and transaction. This is just the loose definition for now. So a join is when we search multiple tables at once, or multiple sources. I'll call it sources. Search multiple sources are sources at once. Whereas in this class, that's going to be multiple tables. We're not going to be looking through multiple databases at the same time. But that's a fairly straightforward expansion once you get to that point. In transaction, the way we're going to use that word in here, that means update the database. Market's squeaky. It's a different kind than I have been using. Go back to the hill and see if it's fired. That's probably really loud on the good microphone too. Squeaky marker right under it. Mostly I wanted to make sure and talk about how we're going to use that word, because it's not the way we normally use that in English, right? We say transaction in normal everyday life. We're talking about going to the store, buying something. That's the transaction. That usage comes because of how we use the word in the course. But we want to separate it a little bit, and specifically, if we say transaction in here, we're talking about updating the database. And I wanted to at least throw out loose definitions of those right off the bat, because I need to use them for our first topic, which I'll put over here. Yeah, that marker's way quieter. I need to get more of those. OLAP versus OLTP. This is the 2 main things we do in data analytics or working with databases in general. What we want from our data. And basically we have 2 types of data. Anytime we do something, there's 2 general categories our data could fall in. It could be the historical data, or the current data. They both have uses. They're both important. Current data is going to become the historical data. The current is the stuff we most frequently need. We often need, or the way we use transaction in normal day-to-day life, right? At that point of sale system at the store, we go self-checkout at Kroger, scan some cans of chili or something, and that immediately needs to go into the database so that the store manager knows to order more. The people stocking the shelves know they need to come, that something's been sold, or they'll at least get a notification when all of it that was on the shelf was sold. So that's the transaction, the OLTP. That's our current data. And OLAP is historical data. And we use them differently. So the historical data, we still need it, just less often. Less often needed and frequently needed. And frequently in this case refers to basically, if not right this second, within a few minutes, we need that data again. So the most current stuff, and historical is less often needed. So that would be at the end of the month when managers run the reports. They need to know all of the stuff that was current data throughout the month so that they can plan for ahead or end of year. They need to know how the year went so they can plan for the next year or longer, make 5-year plans. They need to know how the last 5 years went versus the historical stuff. So that's, these two acronyms are going to show up a lot. Obviously, the one with the enough vowels to be pronounceable, we usually say OLAP, and then the other one is just OLTP. So the historical data, that's online analytical processing. And working with current data, that's online transaction processing. Now just use that example of a sales store. So that's this type of transaction. So updating our database. So that black marker is, need some examples in like red. Maybe this will show up. Does anybody have trouble seeing any colors? I see head shaking no in here. Okay. Want to make sure there wasn't any color, so I should avoid. I've heard if I use a blue marker and a whiteboard, for people that have trouble seeing blue, it might as well be a white marker. This is like invisible for them. So online transactioning process as far as update the database. So that's going to be our insert and delete queries. Insert data, delete data, change data. So transaction as far as update, which sales transactions would follow directly from that, right? Kroger sold another can of chili at the self-checkout. Or probably more than one can of chili. I don't know who only buys one can of chili at a time. And online analytical processing, that's when we sort and filter our data for, I'm gonna go ahead and write decision-making processes. We sort and filter our data for decision-making. What I actually wrote in my notes when I was getting ready is I was maybe the phrase, make it useful. Because a big table full of random facts, like random numbers and words that are all just single individual data points, right? 44, that doesn't mean anything on its own, right? It's not useful on its own. Anybody come across the difference between data and information along the way? Remember what that is? Some of y'all probably heard me say that in the informatics class informatics 109 class a few times. The difference between data and information.
It's unfiltered, right? That is unfiltered information is.
That's one way to say it. The word I usually look for is this one right here. Information is useful. So that one I just put a 44. Doesn't mean anything, right? And we need more information before we can even begin to use it. Are we talking about the number 44 that we can do math with? Or are we talking about the word 44 that would just fit in a sentence like a zip code, some zip code with 44 in it? There's probably one in Indiana, but I don't know which zip code it would have 44 in it. That popped in my mind. I was thinking about my age. So knowing the age, then you can start doing something with it, right? It can start using it somewhere. That's sort of that's the difference between data and information, is make it useful. This class is all about the data. We want those raw facts. One other note I'll put up at the top. Actually, I should put a divider here. I didn't do a very good job making a table on that one. When we get to writing queries before long, OLAP is generally more complex queries. We can have simple queries, right? We can select everything from the database at once and print it out to the screen. That would be a simple one, but at that point, it's not very useful for us because that's just tables and tables and tables full of random data points. Whereas OLTP is usually simple queries. Like insert a somebody's name, their age, and the town they live in into the table of similar data. We don't have to do any pre-filtering to figure out where to put it or anything like that. But we can have complex queries, especially when we get over to that change the data or update a particular field. It might take us a minute we might need to do filtering to figure out which field to change, so we don't accidentally change the wrong thing. That's the broad overview of what we're looking at in this class is OLAP and OLTP. We don't do one or the other. It's not like for those going into data analytics, it's not like you would choose to do one and that's your specialty. There's two distinctly different tasks you'll handle in data analytics. Where are you working with the current data or the historical data is the standard way of phrasing it. But historical, depending on the situation, historical could be 10 minutes ago, right? I'll pull up an example of that. So RSS is really simple syndication, where they send raw data out across the internet. The whole data set, there's no filtering like an API. You can ask for a specific data. You could ask. An API would be over here on the useful part where we can sort it and filter it. But I guess an RSS feed would send all the data out at once. It's like the NASDAQ RSS feeds. Or something that can. So it's just this big set of data that comes out periodically, includes links to some of the other stuff. But they just send this data out constantly, and it's free for 9-minute old data. That's historical. 9 minutes isn't very long. We were talking about this 9 minutes ago. So that's not very long ago, but that's useless as far as the stock market goes, right? If it's 9 minutes ago, you might as well be one of those people that checks your portfolio once every 6 months. So up to the millisecond data is free. Or sorry, up to the millisecond is expensive. Costs a lot to buy that, and there's only 4 places you can buy it from. One of those being NASDAQ, and then when it's 9 minutes old, they just send it out for free. So if you're not doing that current they're on the auction floor in New York or wherever, you can still kind of keep up on it. It's not very old, but the word historical is relative to the situation. 9 minutes is a long time ago as far as the people on the New York Stock Exchange floor. Actually up there in bidding on the auction and stuff. Is it okay if everybody, what's on the board here? Okay. For those who haven't had me in class before, I always try to ask that. So the stuff doesn't just disappear, but in general, it is being recorded, so it's still on the video. Okay, that squeaky marker doesn't erase either. But I marked her away. That took some effort to get that erased. So now, I guess actually getting started into our content. So, whoops. Let me try that again without the typo or without the misspelling. So database, the thing we're actually looking at this semester. Let's start with the actual definition. So oh, that one's not much darker. You'll see that. Okay. Not very. I need to get some more black markers, I guess. A usually large collection the blue one works. A usually large collection of data organized especially for rapid search and retrieval. That is the definition from Merriam-Webster. Which I'm not going to write those names out, but right from the dictionary, that's how a database is defined. Usually a large collection of data organized, I would say specifically for rapid search and retrieval. It's how we store and retrieve our data. Store and retrieve, which is kind of important. Put it in there. It's not how we process our data. So that means we're in storage or hard drive. Storage or our hard drive. Not in RAM. Usually when we're working with software, we're working in RAM, we're working in memory, right? We open a Word document, Microsoft Word opens, we open a new document, we work on that file for a while, and if the computer crashes, like our battery on the laptop suddenly goes out, we lose the file, right? Because we were working in RAM, we were working in volatile storage that whole time. So until we hit the save button, it only exists in volatile storage. Same thing, spreadsheets, playing video games. That happens. Gamers get really upset about that sometimes because the hit points are usually spread out. So you have to get to a certain point before you have a chance to move from processing over to storage and actually get back to the point you were. But with databases, we are in storage the whole time, which is a big thing. So we're thinking about the format here when we talk about it in terms of database. We're not talking about which drive we're storing it on. Talk about how we store it on that drive so that we can retrieve it and get it over to RAM so we can work with it. So there's lots of formats we could work with, but there's a couple, 3 in particular we're going to look at. And probably a 4th one I'm going to add in because I mentioned earlier at the NVIDIA GTC conference, they talked about including that in a lot of future plans. So we might look at that 4th one as well. I'm running big. It's okay if I erase the definition. Sure, just the straight definition. Y'all probably could have guessed at a lot of that already just from the way database shows up in our modern world. The big thing from that definition is it's in storage. So first thing is kind of like those examples I just mentioned, flat files. We just put it in a file. I mentioned a Word document, but Word documents are all about formatting. Some of the characters used in standard Word documents aren't even Unicode values. So maybe a text file, just pure standard Unicode encoding, that worldwide standard of how we represent the letter G in binary code or whichever symbol that we use. We just write it up in a text file and keep it in that file. Put data in file, save file. It works, it gets our data out there. Or we could read file or transmit across the internet. Transmit across network. Probably no surprises there. Technically, this would be a hierarchical database. But don't ever go calling it that. That's just a technicality. The directory structure, the folders on our computer, those form a nice hierarchy. We put whatever our root folder is, there's other folders inside of that. If you're on a Linux or a Mac, you have the root directory, but On Windows, you have your, starts at your drive and you put folders in that, other folders in that, and keep everything organized, and eventually you get down to the files in that nice organized structure, that nice organized hierarchy. Right? Bunch of folders. And then somewhere down to the bottom, eventually we get down to some files. File icon looks like that. But some sort of hierarchy structure. So it fits the definition, which I just erased. We could fit a very, depending on the size of our hard drive, we could fit a whole lot of files there. It's nicely organized so we can retrieve all the stuff quickly. We could automate the process. A computer can dig through its own directory structure. But we wouldn't call that a database. We would never actually use those words. We'd say directory structure, or most people are probably just going to say folders. We'll get some practice with the two most common for the organ. So there's really common in organization. We'll see those. The two most common and when we would use it. Oh, I heard two most common in the notes. We'll see the three most common and when we would use each particular one coming up soon. I guess I could list them out here. Usually we're thinking a little bit more organized than just our random directory structure. But that's what a flat file is. So some organization from that might be like XML. XML or JSON or CSV. Those would be the three biggest ones. XML is best for strictly typed data. We're going to talk about types. That's one of the first, that's the big thing we're going to get into on Thursday. Makes a big deal. Sometimes when we're processing it, we need to know what type of data it is beforehand. Like we can't even start our software until we know that what things are integers and what things are strings, what things are booleans. We have to know that exactly what type of data we have beforehand. It's much, much faster when we do that. It's often still noticeable in human timescales, the speed difference between strictly typed. Or JSON is best for what's called open type data, where we don't have to say that. The software will figure out what type of data we have. But the computer figuring out what type of data we're working with, right? It's like, here's some data, and when the computer figures out that it's an integer, it takes a long time to do that. So it slows everything down. Especially in the days of big data, CSV is comma separated variable. It's what spreadsheets grew out of. We just write all our data in regular text format, the buttons on our keyboard, and separate data points with commas. It is by far the smallest size. So when we get in big data, especially big data transmission across the network, it's a lot better to have the smallest size. And at least overhead, which is a big deal too. So if we went to twice as much data, if we double our data size, XML and JSON will regularly increase 3 or 4 times bigger. But if we double our data size, CSV is only exactly twice as big. There's not any extra overhead that comes with it. So when we get in really big data, or just for optimal transmission speeds in general, that smaller size, those are our flat files. The thing about files, the biggest drawback, well, I mentioned a Word document earlier, think of it like that. We can put our data there, open back up, maybe it's something we're only going to read, we don't need automated processing or anything. Put our data in a Word file, open back up, we can read it. That's no problem, except for this point I made over here about storage and RAM. In order to open that file back up, we have to put the whole file in RAM. How much RAM do we have? RAM is usually much, much smaller than storage, right? Our hard drive is usually can hold way, way more stuff than will fit in RAM. And I use cheap computers. I always use the cheapest laptop at Walmart. Usually it's Walmart. I guess it could be the cheapest laptop from somewhere else, but Actually, hardware is disposable. Oh, what I wanted, one text manager. Windows X, and there it is. So I treat hardware as disposable and just make sure the data is safe, and then I can, whenever something breaks, I throw it away without worries uh, and install the nice, safely backed up data on the new system, on the new hardware. To some extent, like I carry multiple systems. For those I don't have any in class before. I do walk around with 3 laptops and a VR system in my backpack. It's kind of heavy. And like the MacBook only gets so cheap, right? The cheapest MacBook is still way more than the cheapest PC and Chromebook combined. I got 3 or 4 PCs, cheapest PCs and Chromebooks before I got up to the price of the MacBook, the cheapest MacBook. So there's relative things, but on this cheapest laptop from Walmart, where's my memory? Looks like I have 8 gig of RAM. I'm guessing. Yeah, oh yeah, there it is. Knew the number was there somewhere. So 8 gig of RAM. That's quite a bit of space. But how much space is that with modern data sets, really? There are 7 billion people in the world. 350 million Americans. We go with just Americans. It wouldn't take very much data to fill up 8 gig of RAM very, very quickly. Could probably do that with just Indiana, just this data about people, a large data set from Indiana. Don't even need to get into the whole country or the whole world or anything. Data sets can get very large. And granted, this is the cheapest laptop from Walmart, so there are much larger RAM chips, but it's still usually a lot smaller than storage. So the flat file thing, the biggest drawback on it is it's a whole file, and we need that whole file every time. We can't pull one data point out of a JSON file unless we read that whole JSON file into RAM, which can be a bit problematic. So what we're usually thinking about, okay if I erase this? Because he had notes here. So what we usually want to think about is what we're actually going to call databases or databases when we actually use that word. In particular, a relational database is the one we're going to talk about most often in this class. That's going to be our main focus here. So each data point gets its own field. And I'm going to put quote marks around that word as in like it's an important vocabulary term, and you will definitely see quiz questions about it. And midterm and final exam questions that have the words I put quote marks around like that. So each data point gets its own field, which is a cell in a table. Ultimately, but we're building up to a table. I'll put that there. In normal English, we would call it a cell in the table. Related fields combine to form records. To form records. Or since these things do show up in daily life in American 2023, what we call rows a row in the table. All the field, all those cells go together and make a row. Our technical terms can be field and records. Related records combine to form tables. tables are related by common fields. You see why the word relational is in that definition? So everything is related to other stuff. Picture's worth 1,000 words. So let me draw some pictures here. I'm gonna color code. Let's see. Several colors here. So a field is like one cell. One data point. So we have one number in there. I threw out my age earlier, 44. The number 44 goes in there, no context whatsoever. Then we extend that into a record. So there's other fields. I make a really narrow one, a really long one, a couple of really short ones, maybe some other on this side. The different widths I'm putting there will make a difference. We'll get to that in Thursday's lectures. But it relates back to that type thing I was talking about. A great big name, bunch of characters, that takes more to store than an integer, right? Like an age. So maybe this is age. So storing my name needs more space in the database than the age. We don't want to be wasteful with space. This small sets is not going to matter, but remember how much data we have in our modern world. There's a lot of it out there. And then the related ones, we set those up as columns so that all these rows have the same columns. Then a whole bunch of rows making up that table that all have the same thing. Yes.
This example is the field key.
One of the fields would be a key. A key. When I jotted out the small one, I was thinking this would be the key. So like I've generated integer to make sure that's unique. So the first one we insert gets number 1. The second one's 2, 3, 4. Then we have a unique way to identify everything. And somewhere there's more than one table. Things are organized.
That's what I was thinking. I just wanted to make sure.
Yes.
You're going, okay.
Yes, we will get into that in much greater detail soon. I'm going to draw another table over here. That black marker is about done for, I think. So then there's another table with different data. Maybe a couple of small fields, a big field, something in the middle. There's a bunch of data, but yes. Then in this case, this one lines up with our field here. That's why I was trying to color code that if that green's showing. Yeah. I'll leave off labels. We'll get to the labels soon. This would be a foreign key. So if this is used as a primary key here, this field that I marked maybe uniquely identifies each record. Like username, right? We can't duplicate usernames, so so we have the name, age, address, phone number, all of that, and then we have the username. We know that's unique, so there's a special way that we can identify every single record. This table has something completely different, but we can combine, those are like the same field. So we duplicate it over here. In the diagram, when we set up our database, there's ways we can just say, okay, this column is actually the column from the other table, but, and then we don't complete it redundantly, but as far as thinking about it and making sense of it the first time, it might help to think about redundancy like we would see in the diagram here. Let's say, well, just put it over here in this other field. And now it will be a foreign key over here. We'll talk about those words soon, but those are related. And then once we have those relationships, I don't have enough colors. I'll use green again. maybe we know this piece of data right here. We know somebody's name. Well, we can follow the relationships around. So, I don't know, maybe this is name and username. Username's unique, but there's names might not necessarily be unique, right? Lots of people have the same name, but the thing from the name column is going to be related to a unique username. Only exists for that one person. And we can follow that relationship over to there. Well, these are all the same field. So we can follow that relationship over where I drew that here, come down to one of these columns and maybe over to this. Maybe this one has their age. So it's in a completely different table, but we can follow the relationships around and find any piece of data. And unlike the flat file, we don't need our entire data set. All we need is that starting one and the relationships. And then we can find any piece of data in our set by following the relationships around. That's the sort of general idea. Then there's some optimizations we will do this. There's some things that we can do to make that much, much better for the computer to follow those relationships around. But then instead of, right, if we had 9 gigabytes of data, I'll go with that because that would be too big to load in. If it was in a file, it would be too big to load into my laptop. I don't need that. I need a name, which is a bunch of Unicode characters. So that's still a handful of bytes. Just a really little bit of data here. And then the descriptions of the relationships from when we set up our database, or the schema of our database. That's going to be an important word. That's where this is going to show up in homework over and over and over again. The schema of our databases. How are these things related? So we know our starting point, our relationships, and we can find any other piece of data. And only those relationships and starting point got loaded into RAM. Then we filter it down and only bring in the pieces we want. We don't need the whole data set. We filter it in storage instead of RAM is the basic idea. That's what we're looking at here. Have any other? That's what we're going to talk about the most this semester. Certainly not the only kind. It's great if our data set's consistent. So this is a term I'll write up here. If we have structured data, so let's think about a web form. Right? You go to a website, sign up for something, there's this form pops up, you fill out the form, and you enter your data. That's where we get structured data, because everybody that goes and fills out that form is going to give us the same information, right? Like the name, town, I don't know, high school they went to, different things, and maybe over here. Yeah, we can filter things. We have a question we might need. Maybe we want to know when somebody graduated high school. We know their name and their age. We'd have to figure out when they went to high school, so that is spread out over different tables. But we would have the same data from everybody that filled out that form. The table is nice and full. Empty cells cause big, big problems here. One of the things we're going to have to look at is tricks for dealing with empty cells, because what if this one's empty? It's kind of hard to pass through that and follow our relationships around if we hit just a blank spot. So that's structured data. Think of it as a form. Everybody fills out the same form. We have the same data. It goes nicely into our columns. But what about the data we grab from, say, social media? The big disparate set that that is just out there for us to access. The kind that would be more commonly used in targeted advertising. Right? That randomly grabbed from social media. We have one person's shoe size. We know somebody else's, the type of new car somebody else just bought. We know another person's high school mascot. We know the name of somebody else's ex-girlfriend or ex-boyfriend, right? We have this huge disparate set of data, and there would be more empty cells than full cells here. That's unstructured data. So structured data, we have the same data about everybody, every record is the same. Unstructured data, every record is unique. But we still want to have some of those quick advantages, like if we know their name, can we find out their age? And then we can come back over here and look at and see if their high school has, or go to a different database and see if their high school has a 25-year reunion coming up soon or something. We need to sort through multiple sets of data or multiple tables or multiple data sources to find that. That's the online analytical process, that OLAP. It's not just the latest sale added to the database. We need to get something useful out of that collection of data we have. So with unstructured data is when we get in non-relational databases. It's okay if I erase stuff on the board? I'll try to avoid erasing the pictures, and then maybe we can compare pictures side by side in a moment. So that thing I just mentioned, like collecting data from social media, there's a lot of that in the world, right? There's lots of that. And so that's non-relational data, which we will also, you'll more often hear it called NoSQL. I probably should have wrote SQL up there a moment ago. SQL stands for Structured Query Language. It's basically the scripting language we use to do all this stuff on the structured data. But we don't always have structured data. So non-relational is quite a mouthful. So it became common to just call it NoSQL because it's not, it's a lot easier to say. Structured query language, and we just pretend like there's vowels there so we can pronounce it. One thing about that, the name is deceptive because most of them, the developers did put a lot of effort to keep it very, very close to SQL. So that way data analytics people don't have to learn something entirely different. It's still very similar. The one I have in mind that we're going to look at in this class, there's several kinds. The one I have in mind to look at is node vertex. So I'm going to put this class. It's a, I should put the technical term. So this class, we're going to look at a graph database. In particular, the one I use is used by a rather large company. I'll leave names off and stuff, to deliver 400,000 targeted ads per second. That's a lot of data that needs filtered every single second, right? 400,000 every second, and then for the next second they have another 400,000 ads they need to get out. Really, really large marketing company. So they use this one called OrientDB. When I was going to look at, it's a good example. Most of the stuff we're doing in this class is going to relate to relational databases. And I did take a while and dig through dozens of non-relational databases. And OrientDB was the one I thought was closest to what is generally covered in this class. So the structured query language we use here, or anybody at Ivy Tech, so the online ones or people all across the state going off those same major course learning objectives, what's covered there, when they put this database called OrientDB together, they put a lot of effort to keep it like SQL. Anybody that takes DBMS 110 at Ivy Tech should be most comfortable with that. The minimum amount of changes for a whole bunch of other packets.
That one compared to like MongoDB. I've worked with that one a little bit.
very similar. Very, very similar. So, the biggest difference is we have a graphical interface. So we can actually see the graph. We actually see the graph without going to third-party tools. I guess Mongo, people have built that into Mongo, but it's still, any NoSQL is going to be primarily key value pair based, because we don't have nice columns and then headers for all our columns. So we have to basically assign the header for that one data field it goes with. So that'll be a key, and then the value is what goes in the cell. It's the equivalent version of it. Internally, there's a few more differences, but it's very, very similar. I'll pull up a picture here in a second. But mostly as far as what we see in this class, it's superficial. The interfaces look different. Slight different in organization, but there are some internal differences for when you get to advanced stuff. But node or vertex in our graph is a collection of key pairs. So that's going to be exactly the same as Mongo. So he just asked about one of the most popular ones. I decided not to go with that because it would take a lot longer to get into that. Plus, this is the one I use. It's really, really fast. Even if you're used to some good databases, it's like,
yeah, no,
it's
I've been
impressively
wanting
fast.
to do more SQL, more based databases.
Okay, yeah, that's kind of why I did this. There's a bunch of the MongoDB sort of stuff. Other people might be familiar with this. I believe Greg did use some MongoDB previous class. There's a lot of the key value pair stuff that's the same, but then it's almost identical to SQL when we start typing our queries. Okay. Very, very similar. All the keywords from SQL were put in there so we can use a lot of those, which makes it easier to work with right off the bat. And that's roughly equivalent to a record. Roughly equivalent to record. So basically we take this whole record right here and we'd make this unique node or vertex. And there's going to be several. So maybe this one we know somebody's name, where they went to high school, the kind of car they drive, and then the person over here. Another vertex, we know their cousin, and we know their shoe size, and we know what their favorite restaurant to eat at is, stuff like that. So we set up all these different nodes, and then we uniquely identify the connections between them. So we create an edge that connects those. Maybe it connects that one, and this one connects there. So all those are connected. And we uniquely define each connection. I'll put that in blue since I drew that. And then our edges uniquely define each connection between records. So that's what we'll mostly look at this class, relational databases, and then I want to throw in some NoSQL databases. Let me pull up a picture here. That one does have a nice little interface we can work with. We got 20 minutes left. Okay, yeah. So for the NoSQL databases, let me just pull up some pictures. Orient DB is the one I found is closest to just working with a basic regular relational thing. There's a lot of similarities between them. Some of them go to extreme difference or extremely different, or you need to go with. I just wanted to pull up a picture for now. So this is what a graph looks like. So each one of those little dots is a record. So maybe it's like, somebody's name and their pets' names, and then that connects to somebody they went to high school with. That connects to another person that the person they went to high school with just bought a used car from. And we uniquely form those connections each time. And that picture I pulled up there is an interface. You click on one of the dots and you have all the spots to type in and stuff. You don't want to just script it in a text file directly. If you script it in a text file directly, it's almost identical to mine. But that third-party tools are available for that. Have you used any of those?
A few of them. It's mainly just like I've tried to implement it in some like Python
Scripting stuff. Okay, yeah. So yeah, it's similar to that. Internally, there's differences, but until you get to that point, okay, yeah, and they can go very, very large.
Single.
Yeah. Yes. Yeah, to organize all of our non-structured data, because, well, structured data can fit in a non-relational database. That's fine. We just have to define everything itself. But when we do that, we end up with extra work because we could have just gone with column headers instead of keys in every single data point. So it leads extra work. It leads to extra work if we put structured data in a NoSQL database. And if we try to put the unstructured data in a relational database, we end up with those empty cells that can cause problems with the relationships around. What I was going to use, I'll pull it up here. So there's two ways. I wrote up some instructions for installing it. There's a local virtual server called XAMPP for our MySQL part, which we'll probably use. This works on every system. I regularly run this on all of my different systems. So Mac, Windows, Chrome, Chrome OS, Linux. It's a virtual Linux machine, but it does still work if you're running on a Linux machine. But if you're running on a Linux machine, you might as well just use the actual one. But on all the other ones, I do regularly use this. It gives us a local virtual server, and it comes with a MySQL database on it. Which if I come in here and go to localhost, built-in thing, but PHP MyAdmin is one of the most popular interfaces for working with a MySQL database. It's recommended by the biggest names in the easy to develop websites where you're dragging your mouse around and building a website that way. They recommend this for your MySQL stuff. So that's why it's overwhelming in popularity. Real easy to use. Have a place to input the SQL code itself, or there's lots of different, I guess I have to choose database. Do I have a database? I don't have any created here yet, but I just put it back to a blank state the other day and deleted all the non-built-in things. We will get to that soon. That's probably where we'll do our examples. Some with that. I guess I could just do smash the board and create a new one. But we also have a regular graphical user interface or GUI text fields and buttons to work with. If you've never seen a MySQL database, there's a lot of stuff MySQL can do. So for buttons and text fields that control all of it, it is an overwhelming interface to say the least. There's a lot of stuff there. We're going to spend a bunch of time drawing ERD diagrams, but this will actually generate the ERD diagrams for us. I can probably do that from the building ones. So if I go to like say users. Oh yeah, MySQL. So I go in here and come over here and go to design. There we go. This is kind of a complicated thing, but you see all the little different versions, different things about the table. Not going to fit well. Here's a small one. So in roles mapping, there's like four different columns in that table. So we'd have all the stuff there. I was looking for users. Oh, users is gonna be small. So for user, we have all this stuff. So what server do they have access to the database on? Because we can spread it out over multiple systems. We'll talk about that. The username, the password, and all those different columns that would be in the table. And at the same time over here under structure, so there's a user table. There it is. Here's what that looks like in table form. Or we can click on it and edit all that, or we have the script in place. So that's the one I use most often in my own projects. So that's what I was going to use. It's a MySQL database. We could always just go to the terminal. There's X, open the terminal, and I'll jump over to Ubuntu because I'm pretty sure I have it on here. I'm pretty sure I have a MySQL on here as well. So if I do sudo MySQL. Maybe I don't have it on here. I'll get that set up and we'll look at a terminal example here in a couple days. I would need the whole address to connect it there. But we can connect to this database from a terminal and do all our work right there as well. But it's apparently not on that virtual machine. At least not the one I just tried, unless I made a typo, but we're running near the end, so I wanted to look at that. So there's a local version you can try. I've used that on all the different systems. Works on Windows, Mac, Chrome OS, and Linux. So any major operating systems you're using, it'll work fine. It's a virtual Linux system, so if you have a Linux system, you can just do it directly there. I'll probably show you how to do that as well for those who run that system. It's also, that's available for free on free hosting sites. Some of y'all are familiar with this one. So this is one I've been using for a couple years now. It's a free hosting site. It's related to a big name one. Their icon's a blue alligator. I can't remember I'm gonna say blue alligator, whatever that big hosting site is, the blue alligator logo. This is their free version, but they came up with the idea to show ads on the back end. So that advertising they show on the back end pays for a lot of functionality we don't have in most free hosting sites, which is really, really nice. And I'm used to seeing ads everywhere I go anyway, so it doesn't really feel any different. So here's the one from the class last semester. So if you use the file manager, you just upload stuff to an Apache server and host a website. But under control panel, with the ads on the back end paying for stuff that we don't normally have, most free hosting sites will give us one, maybe three databases. So we can choose Postgre, MySQL, a couple versions of MySQL, but if we go in MySQL, get past that ad because that's paying for everything, we get 400 databases with every account. And that's databases, not tables in your database. I believe it's a 10 gigabit limit as far as what goes in each database. So that's a lot of data you can put on there for free. So that's what my recommendation was going to be for that. So I just make a new one real quick. In class. So we got this new one, and so here's that one I just created. Then over here in the admin button, there's a MySQL database, but you'll notice we don't have that tab to get back to the server. They handle, so on that local host, had all this stuff at the left, like on the actual server itself. So they handle up to that point, and then basically they'll say create the new database button. So like when I just match the keyboard here, and then from this point out, when we fill that database up with tables, design a bunch of tables for it, then fill those tables up with data. It's the same whether it's here or on this free hosting site. I wrote up the instructions for them, but again, kind of realized I was going to be teaching the class in a hurry, and I've been rushing through things. So I want to do at least one edit pass before I publish those instructions for you, that they're ready. And you can choose which one you want to do. And then notice there's an export button. So after you make your database, you can export, like your group project, you'll make something equivalent to that export file, only to be imported and set it up. And then for your homework assignments, after you get set it up, you'll just export that and send me that file. And then I'll import it and recreate the exact database you exported to grade the homework where we're actively doing things. A lot of concepts and stuff though. So either one of those is fine. It's infinityfree.net. You get three accounts. Each account's basically a different website. And then each website you can get up to 400 databases on. And then you can just fill those databases with tables until you run out of things. So I think on their ad, they just say virtually unlimited. Because if you're looking at a free hosting site, 400 databases is unlimited compared to what everybody else gives. I have the instructions. I will get those out to you soon, but one of those will get set up soon. So we will actively be doing things. I guess I'll show OrientDB. OrientDB, if I go to the download page here, which is in the same instructions, it looks like there's a bunch of different things. It's cross-platform, that every one of those buttons actually downloads the same folder. But when they didn't put like the Windows version or the PC version, it really confused people. And they were just getting bombarded with questions of, how do I download it for Windows? So you would click the one for your system, but they all download the exact same folder. It is completely cross-platform, which is really, really nice. The 4 in the top row are the same, and the 2 in the bottom row are the same. But there's 2 versions. We'll use one of the ones in the top row for this class. But they all download the exact same thing. But when they only gave this button right here, it really, really confused people. They couldn't figure out what to do. They didn't trust, I guess they didn't trust them that it was really cross-platform. That's the NoSQL one that I thought was the easiest transition to make after what this class covers on the relational databases. Okay, that's probably going to be our longest class day. Does anybody have any questions? A couple seconds. Okay, yeah, so we're scheduled to go to 350. Today's probably the longest class day, and then we'll have time to actively do stuff. And it won't just be words on a board. We'll go over to one of the databases and create 2 versions so we can compare side to side and really see what that word means, not just memorize the definition. That way it's more useful. There's going to be a lot of that in this class. So hopefully it's going to be a lot of fun. I really find data fascinating. Yesterday in my admin hours in the office, I just read pure data sets. Just to check out how the first 8 weeks went for the schools I do the paperwork for. The department and the half of School of IT here that I do the paperwork for. Just digging through everybody's data, and I was reading the pure data in table form. I didn't even bother to put it in like nice colors in the spreadsheet. Some of us find that really, really interesting. That'd be really, really interesting. When we put it back together and can do useful things with it, it'd be really fascinating. So hopefully it's going to be a fun class. Yeah, I think it's been more than 5 seconds since I asked if anybody had any questions. So I assume the silence means no questions. Excuse me, if you have any, let me know. Otherwise, y'all have a great day, and I'll see you on Thursday. We'll kind of get started into the content heavily.